Just a quick review from last time. Let's just do a couple of quick joins here back to the employees table. In order to get data out of multiple tables at once, and it's very rare that you're really asking for data from one table. Normally it's from lots of tables. To get data from multiple tables, we need to join them together. So if I want to know the foreman's name, excuse me, and the employee's first and last name, which I think are under first name and last name, and the trip date and the destination. If I want to know all that, those three fields come from, or that group of fields comes from three different tables. So I need to tie those tables together. I did finally remember, right, to send you the ERDs for Premier Products and Henry Books so that you can see those. Remember, this one on the board is pretty simple. Plants have employees who take trips, so it's a chain of events there. The way I like to link them is in that order. I'll look at that ERD and say I'm going to make these links. So I want this from the plants table joined to, and remember you can say inner join, don't need to. Join to the employees table, and then you use the using clause, plant ID. That's the field that the two have in common. If you look at the ERDs that I sent you, every pair of linked tables, you should be able to see a field that they have in common. That's what you put in this using parentheses. And this is the easiest way to join those tables. And Tyler sent me an email saying, what's the difference between using and on and where? They all do the same thing. This is just easier because you don't have to list the ID twice. So it's a little shorter. And I don't like using the where clause to join tables because to me the where clause should be used for filtering data, not for joining them together. But that's just my philosophy. It works. But my advice is use the using clause to tie your tables together. But we still need the trips table, so we just keep going and join that to the trips table using what trips and employees have in common, which is the emp ID. From there, I can still add a where clause where the destination equals Chicago and the trip date is in February and I can add as many clauses to this as I need to. If I were doing statistics, I'm not, maybe we'll do another one here in a minute. If I was doing statistics, I could add a group by clause here and a having clause here, and I can use an order by clause. So all the clauses that you learned about in single table queries, you can still use when you're joining multiple tables. The only thing that's different is you have to figure this part out. How do I tie these tables together? So then we can order by trip date descending, or whatever we want it to do. Let it rip. And it says no, because Alexa Mara doesn't have that. Okay, I suppose I should use the right table. There we go. In the workbench, you can double click it, or you can type the using command. Still not happy. Employees plants doesn't exist. Really? Is it all TBLs? Been using too many databases, I can't keep it straight. Yep. Okay, so TBL plants, TBL employees, and TBL trips. One more time. And my laptop must be tired. Okay, so there's all the trips to Chicago, sorted by date, plus the foreman's name, plus the employee's name. 3 different tables information all tied together. The way I picture this, when you join tables, when you join these first 2 together, takes those 2 tables that you see in an ERD and basically draws a line around them. Let me try that on the board here. I know it doesn't record very well, but we have the plants table that's joined to the employees table. And when we join them, the way I picture it, it just makes this big table. One big table. But it only links these together wherever they have a plant ID in common. So if I have an employee that has not been assigned to a plant yet, they will not show up on the list. That's part of what we're going to talk about today. If I have a brand new plant that doesn't have any employees assigned to it yet, it will not show up on this list. So this big table includes all the data from both of these, but only where they link together. And then we said join that to the trips table. So the way I picture it is this big box gets joined to that table. And so sometimes the order that you build these things in, those big boxes get built. The sequence that you do this in makes a difference. Sometimes, I don't think in the assignments that I've left for you that there are any of those circumstances. You should be able to join this to that, to plants if you wish. You can join employees to plants and then employees to trips if you wish. The order doesn't seem to make any difference in the queries that you're doing. Other times, it will make a difference. And when I do that second join, now I've got this, but the only people I'm going to get in the results are people who are assigned to plants and have gone on a trip. You might remember that last week we created a record for me, and I could take this trip descending out. We created a record for me as an employee assigned to the Coloma plant, but I've never been on a trip. So when I execute that, we get lots and lots of trips. But if I were to, these are all still, why are they still Chicago? Because it didn't go away. Oh, I took the order by clause out, dummy. Order by last name. Give me all the trips. And if we look down here under Gall, we'll see there ain't one. But I am in the database. There I am. Okay. I'm in the database, but how come I didn't come up when I said, give me a list of all the employees who've taken trips? I didn't show up in the list because there's no connection there. When you join two tables together, you only get the records where there are corresponding records in both tables. Because when you say the join by employee ID, they have to have employee IDs that match, and there are no trips over here with employee ID, whatever my number is. I have 6565. There's no trips for 6565, so that record never shows up. It's only where they match. Let's do one more quick example with statistics just to show that we can do everything. I'm actually going to steal most of this joining stuff here, so copy that, paste it underneath here. And I need something that I can do math on. Do I need all that stuff? Let's take the destinations out and the trip dates out and put in expenses. And I don't just want the expenses, I want the sum of the expenses. And you know what? I don't think, we'll keep the format, it won't hurt anything. So once again, I've got fields from 3 different tables. Give me the foreman's name, the first name, the last name of the employee, and the sum of their expenses from plants, employees, trips, using employee ID. So my join is complete. And let's see who's got the most. So let's give that a name as total expenses. And remember, when I create an alias like that, you might see that in some of your evaluation that say you could use the alias or you forgot the alias. That's the new name that I've given my calculated field. And I can use that in an order by clause, but we saw last time that you, or actually in the single table queries, that you cannot use a calculated field in a where clause. It's one that tends to people forget. Order by total expenses. Descending. That way I'll get all the expensive people first. But what I've forgotten, there's my order by clause. Whenever I have the sum, if I run this right now, I'm going to get some really weird results because I didn't say to group them. Let's just see what kind of weird results we get. I think everybody's going to have the same answer. Oh, I get one. Why did he give me Richard Femmer? I have no idea. Why did he give me Robert Zula? I have no idea. But here's the grand total, $146,000 that we've spent on expenses on what the data that's in here. But that's the grand total. These names really don't mean anything. I need to group by. And remember the order of the clauses, the group by comes first. So I'm going to group by last name, first name. It's not the same order they're in up there, but I think it should be okay. Let's find out. Okay, so now every person, and these, remember, these are foremen, so that's why there's doubles here. These are the foremen of these people. But each person is in here, and Mr. Zhu here, I assume it's a Mr., I guess I can't tell. Mr. and Ms. Zhu here has spent a total of $4,700 on trips, which is a whole lot more than a lot of other people. I'm going to order them by name now, just so we can see that these first names are only coming in there once. And I think I'm going to move my foreman to the other side. So get the names, and then the foreman, and then the totals. That way we can see the names a little better. And I'm going to order by last name, first name. So I can see that each person only shows up once. I don't see any duplicates. So that shows us that each one of these is unique, and this is their total. What it doesn't show me is how many trips they've taken. We could put that in here as well. That means I want to count. Remember, we always do a count star. A number of your single table queries have come in and you're not doing a count star. You pick some other field. It'll work. You're a little bit at risk because some versions of MySQL, if you say count the first names, and there's 6 Tylers in the list, it won't blend them together. It'll only count them as one. So you got to be careful. If you do a count star, it basically says just count records. Don't worry about the field, just count the records. So normally that's the best way to do counts. And this is going to tell me how many times this foreman or this person has been on a trip now. Looks like everybody's going on 6 trips. That's what happens when you generate data randomly. So the other thing we could do, we have one last clause that we haven't put in here, and that's the having clause. The having clause comes after the group. Remember, the having clause is only used to restrict statistics. It's like a where clause, but it's used on statistics instead of on a field. Okay, so if I say where the total expenses is something, I don't think that's going to work because it's a statistic. So I have to do a having total expenses, and yes, you can use the calculated field here. Total expenses greater than, let's say no, there weren't any 5,000, it's $4,000. Right now I have 50 records because I have 50 employees, so they're all here. Go. And now I don't get 50, I get 7. And all of them are greater than $4,000. So all of the skills that you learned in single table queries, now all of the skills that you've learned to join tables together, and when I say all the skills, it's basically just linking these things together, allow you to create very complex queries that draw their data from many different tables and generate statistics or calculated fields from all over the place if that's what you really need. Also remember that if I want to, let's do one more query here. If I want to leave a table out, like employees, I don't care about the employees. I want to know how much money are we spending, how much money is each foreman's people spending. Now I'm going to group by foreman. And order by descending. Let's do the total expenses again. I'll take the having clause out. Maybe. Okay, so now I'm saying give me the total expenses based on foreman. So for each foreman, tell me how much money those people have spent. His people or her people have spent. What's different about this query is I've got plants and I've got trips. I don't have any fields anywhere here, not in the where clause, not in the order by clause. I don't have any fields anywhere from the employees table. Doesn't matter. I still have to link employees in here. I cannot link plants to trips because they have nothing in common. What they have in common are the employees who took the trips. And so I have to put that other table in the middle. That's another reason I gave you the ERDs. If you're looking to link this table to that table, unless there's a direct link, you've got to find a chain. Any chain should work. There should only be one. In the real world, there can be multiple ways to get to those tables, and sometimes the way you get there makes a difference. But that's beyond the scope of this course. So let's run that one. I'm making these up as I go. I hope it works. It's like they're all pretty even. This guy's a little low here, but they're all pretty close. And that's kind of information you can pull out of these databases, is how are we spending on a plant by plant basis. Here it's pretty similar, so no big worries. Those are the kinds of questions you can ask. Let's go back now. Any questions? I'm sorry. All right, all of that's basically review. Lots of review, though, some of it from single table queries, some of it from multi-table queries. What I want to talk about today, and that'll be, I'm pretty sure, the end of it, are outer joins. We've done inner joins. Remember, we left the word inner out. What an inner join means is only show me the records where there is a match in both tables. That's an inner join. There has to be a match. But what if I wanted a list of the total expenses by person, even if the person like me has never been on a trip? An inner join's not going to work because I've never been on a trip, so it has nothing to calculate, and my name doesn't show up at all. Occasionally, you'll want queries to say, give me a list of all the employees and how much money they spent on trips, even if they've never gone. To do that, you need an outer join. What an outer join says, let's see if you can hear me in the recording. What an outer join says is give me all of the records from one of the tables in the relationship, one of them, regardless of whether there's a match in the other. You don't put the word outer in, just like you don't have to put the word inner in, but outer is not even a keyword. They're called outer joins. Well, they come in two flavors. There's a left and a right. I've never done a full. The full says if there are trips with no employees, put them in. If there are employees with no trips, put them in. And that's just very, very rare. And often you get lots of duplicate data when you do that. So it's usually either a left or a right join. How do you know whether to do a left or a right join? First of all, let's create that list of employees and trips again. So I'm going to select the employee's first name, last name, trip date, destination, and expenses. That's two tables, the employees table and the trips table, from TBL employees joined to TBL trips using the employee ID. And let's order those by first name, last name. Now this is still going to give me a list without voc or gal on the list, because this is an inner join. If you don't specify otherwise, it's an inner join. And so if I run this, we did this before, but just so we can see where we're starting from. How did I sort those? I don't like, okay, so vocer would be down here under the V's. First name's way down at the bottom. TUV should be coming up soon. I'm at the end, there's no vocer. I don't like sorting them like that, it makes me confused. And it makes my laptop confused too. Okay. So, no voc or gal, go from franchise to Hampton, no voc or gal. But again, imagine if I have 3,000 employees, and many of them don't go on trips, hundreds maybe. How would I know who's missing? When you've got 3,000 records in your results, how do you know who's missing? Unless you're looking for somebody particular. And so these outer joins allow you to say, I want all the employees, regardless of whether they've been on a trip or not. So we need to change the join to either a left or a right. Which one? The one where we expect things to be missing. Another way you can look at it is if you look at those ERDs I gave you, there are 1s and M's. Do you remember from last time, what does the M and the 1 mean? Many and 1, but 1 is the parent table. One employee has many trips, but a trip is only taken by one employee. Normally when you do these outer joins, you want to point to the parent. So the one side of the relationship. What I mean by point to is on which side of the word join are the employees? To the right or to the left? Well, I got it on a separate line, but if I put them on the same line, on which side of the word join is the table of employees? It's on the left side, so you use a left join. That's all it's about. Which side of the join, which side of the word join does the table that is the parent show up? Now, it doesn't have to be the parent, but normally that's what we're looking for. The assignment would say something, give me a list of all employees who've gone on trip, or give me a list of the trips that employees have gone on, but also include all employees, kind of hear something like that have not gone on a trip. Get the same answer. Not exactly, because in this, exactly. What happened? Did I run the wrong one? Didn't I run that one? Where did I put the left? There it is. Okay. Left join, trips, order by. That should have worked. Oh, there I am. It scared me there for a second. I think I was looking between E and F instead. There I am. Notice that for my trip date and my destination and my expenses, it says no. Any other employee that we put in here who's never been on a trip will show up on this list, and the dates will be null, which is your visual clue that vocer's never been on a trip. Pretty obvious, right? The word null means nothing. I don't have any trips for this person. Everybody else has got trip data. This person, at least on that trip, had no expenses. But I still show up, even though I'm not in the list. That's all there is to an outer join. Not all. There's a little bit more here. But that's the primary focus of an outer join, is to say, give me all of the records in that table, one table or the other, regardless of whether there's a matching child record to go with it. We could do the reverse and say a right join here. That would say, give me, here's my join. On the right, say, give me all of the trips, is what this is saying now, regardless of whether or not there's a matching employee. Huh? I got trips in here taken by somebody who's not in the employees table? How could that be? Well, that's kind of the point of the query. Go find me orphans, is what they're called, trips with no employee. Maybe the employee no longer works for us. We deleted them. Bad plan. But that might, this is a common query, the one that's up there now, or is an example of a common query that people run to make sure that there are no orphan records, because if there are, something's wrong. Maybe I entered the trip record manually and typing in Volker's number 1 or 56565656, maybe I mistyped it. And now there's a 5666 at the end, and that employee doesn't exist, and that's messing up my information because it said Volker never went on a trip. And maybe I'm Volker's supervisor. I'm going, what are you talking about? He just got back from Fort Worth. Where's his Fort Worth trip? So they might run this query and say, give me a list of all the trips, even if there's no employee, and then I can look for the null. And if there's a null there, that means, and if I run this, there won't be any. But if there were a null there, I can look through. And there's a null in the expenses, but not in the trip. Right? There aren't any. There are no trips without an employee. Good. The database administrator might run that query just to see if he's got any bad data out there. Now again, databases like this, very few people have databases like this without some kind of a web-based program, a mobile program, a desktop C# program that sits on top of it at kind of this level out here in front of the board. Nobody touches the database directly. You use the program. And if the program's well written and well tested, it's impossible for me to mistype Volker's ID number in the trip table because I never have you type it in the first place. You pick Volker's name, it stuffs the ID number in there automatically. But this is an example of why you might do not a right join, but a join that points to a child table instead. We're looking for orphans, not in your homework assignment. One of the things you have to be careful of now, I'm going to go back to a left join. So left and right, my advice is just write it, and wherever the word join is, figure out which all you want, all employees or all trips, and say left or right. The one thing you have to be careful of, though, is if you add a where clause to this. So let's say that I want expenses that are higher than $800. I run that, and I get a nice short list, but if I come down here under the G's, wait a minute. We said join them together with a left join of the employees table, so I should get all the employees, right? Isn't that what left join means? Give me all the employees. Where's Volker? He's gone again. And this comes back to these boxes that I was drawing, and now I've got boxes in the wrong places because we're not connecting these tables. We're connecting employees and trips. we joined them together. And once we joined them, we got this big long list. And then we said, now filter that list and only show me the employees whose expenses are greater than $900. So it counteracts the left join. The solution to the problem is to change the word where to and. Now, I don't think this is going to work. Nope. And we have to change the using back to the on. Ooh. On. Now I need aliases to make my life easier. Remember, we can rename these tables. On e.employee_id equals t.employee ID. That says match them up wherever the employee IDs match. But use a left join, so give me all the employees. But this also says, and join them up if the number is greater than 800. Try running that. What I expect to get here is all 50 of my employees, even if they've never gone on a trip that costs more than $800. All employees. Right now, where's my count here? I have 57 trips. That number should go up. There's Annette. Says she's never been on a trip. Well, we know better, right? Because the only person who's never been on a trip is me. This says Annette's never been on a trip that's more than $800, and I can see Annette's name here. Again, if I flow through this list, it's kind of hard to say that Louise and Alex and Volker and Jason, they're all missing. How do I know who's missing if they're not on the list? What a left join or an outer join allows us to do is include everybody, even if they don't meet the criteria, but they get listed with a bunch of nulls next to them. Now that I've put you through that, I don't think there is an assignment in your homework that says do an outer join with a criteria. Let's see if I'm lying. If I remember right, and I'm doing you a big favor here, this is your early Memorial Day present. If I remember right, there is only one outer join in the homework assignment. So let's go look. Here's the brand new and improved multi-tables query assignment. For each order, list the order ID and the date, and it doesn't say anything about list all of the customers, even if they haven't placed orders yet. That's another example where I might use an outer join. A lot of times that's the question. Give me a list of all the customers who have never placed an order. How do I know if they've never placed an order? Using an outer join. But that's not what this asks. The only one that's an outer join, I think, wait a minute, that's the wrong one. I'm in the wrong class, excuse me. That's the one that the other guys had to do. Here's yours. Okay, same question. A lot of these questions were the same, but notice it ends at number 13. For each part, list the ID and the description, how many units we have in inventory, who's ordered it, how many they ordered. All parts should be included in the list. All parts. That's your clue. Because even if a part has never been ordered, it's so brand new, it barely made the catalog, it's still in the inventory, we want it on the list to say it's never been ordered. Or it's a really stupid part that nobody wants. It's never been ordered. We want to know that. That's what this query would do. Then it says order them for the parts that are not currently on order, that have never been ordered. The ID number and the unit number of units should be blank. That might say null instead of blank. Because the part has never been ordered, so it doesn't show up on an order. order the results, sort them by part ID. Nowhere in there does it say where the cost of the part is more than $100 or something like that. It doesn't say that. So you should be able to do this just by joining the tables, stick the word left or right in there. Left or right has to point to a table. Which table do you want it pointing to here? Get to go to lunch as soon as you answer my question. Which table, left or right, are you worried about? What do we want? All of. All of parts. So wherever, when you do your joins, whichever side, left or right side, part shows up on, that's the direction you make it go to. Believe this is the only outer join. Find the book ID greater than, type subport. Yep. That's the only outer join that you have to worry about, is number 13. Everything else just straight joins with a few other little tips and tricks thrown in there to try to mess you up. It's the end of your introduction to SQL. As you can see, there's a lot more complexity to it, right? And even what I teach the students in RDD, there's a whole lot more to MySQL. We haven't touched if statements. We haven't touched case statements. There are such things. There are loops. Even they don't see those. But from their perspective, if you know about if statements in C#, switch statements in C#, can't be that much different in SQL, and they're not. We just don't have time to talk about them. So this is your brief introduction to kind of give you an idea of what's required to get data out of a database, to create them, to put them in. What we haven't talked about that I have talked about to my RDD folks is security. What if I hire Bobby to be my database assistant, but I don't want her getting at some of the sensitive employee data, like social security numbers and salaries and those kinds of things. There's security built into most SQL languages to say, only allow Bobby access to the employee tables, but just these fields. That's all she needs. If you're curious about that stuff, go to my relational database development page. The rest of SQL is out there. My notes are there. If you need it, somebody says, do you know SQL? And you go, well, yeah, it's spelled SQL. Well, good, you're hired. Now go out and do this stuff. My notes are there. Google's there. As you saw, my SQL dev site has a whole manual that's almost indecipherable, just because it's complex. But that's your overview of SQL. It gives you a pretty good feel for the kinds of things that can be done. And hopefully it gives you, I feel that you're just scratching the surface and there's a whole lot more power to it.